Hello, my name is Brittany Richardson, and my partner's name is Colin Demps, and we will be reviewing the image extractor. For our introduction, we will be discussing the dominant color descriptor, DCD. It is widely applied in the image retrieval, taken as one of the MPEG-7 color descriptors. DCD describes the representative color distribution and features in an image or a region of interest through an effective, compact, and intuitive format. A novel image retrieval method based on the fixed numbers MPEG-7 dominant color descriptor is proposed. The feature extraction process does not need the intervention of the threshold value, and the dominant color number is fixed as 8. The histogram intersection algorithm is used to measure features, simplifies the similarity computation complexity. The experiment results show that the precision and recall rate of this method is higher than that of non-fixed numbers dominant color retrieval method. CBIR, content-based image retrieval. CBIR extracts features from images to support image search. In this tutorial paper, we will review some of the basic CBIR algorithms that derive color, texture, and shape features, and will then show how image features can be extracted from the compressed domain, in particular from JPEG images, without the need of completely decompressing the image. Some of the methods that we will be using are DCD extractor function, database program, similarity function, CBIR program, and we will review those at the end on our MATLAB. So let's go over the steps that we did for our project. So step 1, we created our database for the 1,000 images. And doing this, we created a script to store the images as well as the DCD features related to file names. Image is imported into MATLAB. Next, the DCD extraction function is called to receive a vector of DCD features. We then store the features and file name in a structure array imgdb. To retrieve all images, a for loop is created. Next, our next task was to query the database of images to find a specific file. This is done by having the user select a file name and import that specific file into MATLAB. Step 3. In this step, we are looking for similar features from the image the user has selected, and features from similar images in the database. DCD matching function is used to find these similarities. Step 4. We finally retrieve the top similar features through K, in which K equals 20, from the database images by reviewing the similarity score. A score of 0 or 1 is given. 0 is given for not so similar, and 1 is given for similar. We sort the feature similarities in descending order. The first K-score given is the most similar to the original image. The features are mapped in which the similar features will show in the corresponding features. So this is a picture of how our top image would look. And this is our K20 of the images in our database. So now we are going to look at our functions and scripts. So let's start with where we would start to run our functions and scripts at database. We first start by building the IMG database structure array with the specified field and values. Next, the folder path implemented into workspace is done. The image database is created with path to folder with all images included. A for loop that extracts the DCD features and file names from images using the index and DCD extractor function is given. And finally, we save all of this to the database. Let's go to our next thing, the CBIR. This is an implementation of query by example. Allows a user to select or enter the name of a file and import the specified file into MATLAB. Query image is saved as QIM. DCD features extracted from the query image is done next. Database files are loaded. Initialization of similarity score vector is done next. Calculation of dominant color similarity score between the query image and all images in the database is next, which is done with a for loop. We use similarity function as explained previously to calculate the scores. We next use the similarity score and sort in descending order. A 5x5 subplot is created for the for loop to show the top 20 images and query images in window number 1. Next, the query image shown on the first panel of the first row is given. A for loop that displays the top 20 scores in the subplot is given next. Image files for top 20 are imported based off their index in IMGDB. 5x5 subplot created to show the top 20 images starting at Windows number 6. And finally, we display the final image that is similar to the image that the user asked for. We're going to go to our similarity function next. Our similarity function is the function that calculates the dominant color similarities used in CBIR, and it then is used in CBIR MATLAB file. And finally, we will review the DCD extractor function. This function is used to find dominant color descriptor. The input is to find DCD extraction in IMRGB. We'll use this in database MATLAB file and convert RGB to HSV to color space. Next, we will use the quantization in HSV space. We will then create a histogram, and finally, at the end, we will create the DCD feature vector. All right, and we are finally at the end of our presentation and the end of our project. Thank you guys for joining us and reviewing with us all of our information related to the DCD extractor, as well as our similarity function, our CBIR, and our database. Again, this is Brittany Richardson along with Colin Dipps, and we thank you for tuning into our project. Have a good day.